testing, then we try our best to develop and test the application in an environment similar to the production one. So we can say, okay, when it go to the production, it will work as per expectation. And of course, we should have an automated build and delivery system, like building the application or building the container or storing the software packages somewhere. Instead of someone log in and do it, we should have an automated system in place. Now, so this is another or a key component in a DevOps system. Like we should have a source control management or ACM. You can call it a source control management or version control management. There are different names and different level of features. It's a best practice for keeping your source code with an option to with a feature to track the changes. So whenever you make changes, let's say you have a software working, one of the button you want to make from green to blue. It's a simple change, but still you need to track it and make sure everything working. So if there is a issue with a new update, you should have an option to go back to the previous version. Source control management systems or this kind of softwares will help you to implement these. So we know there are some of the logos, maybe you are familiar with that. The Git servers, Gox, Git, some of them are open source and free. You can install on your laptop or on-premise servers. Some are enterprise and SaaS solutions. And like GitHub, you should have like a connection to the internet kind of thing. So this is very important because earlier days we keep the software somewhere as a files. Now we don't keep it as a files. It's more like uh, files under tracking. So whenever there's a change, it will be tracked using the branches, using the commits and all. So this is a simple screenshot from a Git repository where you can see there are changes happened by a user or developer, and you can see the details or the commit history, like okay, it was happened this, and if you click there, you will see okay what happened actually. Also, you have an option to create multiple branches, and you can create different branches for it's a kind of a copy of the original one, but you can have a multiple, like for the development branch you can have a stable branch, you can have a feature branch, bug fix branch kind of thing, so that still you have a original copy which is working. So in case anything goes with okay, version 2.12 is not working, you can simply go back to the 2.11 and get the working copy. So source control management is an important one. Okay. Now we talk about the CI/CD. So we have a CI/CD and another CD. So one is the continuous integration where you push the code, then it should be tested, validated, and merged to the main software repository. This is called the simple CI, which is continuous integration. Once you tested the code, you have to build the application. So it can be a jar file, it can be your a container image, it can be a Node.js based code, which will be stored to a central repository like artifacts or kind of a source control management, or it can be a container registry. This is a continuous delivery. And we have another CD, which is a continuous deployment, where the tools will take care of the deployment of the new application to the production system. So it will take care of the deploying a new container image, or it will take care of deploying the new software package on the target system by overwriting or cleaning up the existing folder kind of thing. This is called continuous deployment. And we have several tools available for doing this, including Jenkins, GitLab, GitHub Actions. Yeah, you know the logos already. Now, so we know the DevOps CI/CD thing. Now we know that it's like a big ecosystem. So we have a lot of tools available for uh, CI, building, testing, deploying. Even okay, if you have a GUI based software or applications, still you have a lot of tools available for testing the GUI based uh, tests, like integration test, regression test, or kind of thing like a Selenium and all already. Then for the building, many tools available like Gradle, Maven, Grunt. Yeah, you can see the logos. Or now we will start with Ansible. So before we go to the Ansible, so what will happen when you push a code change? So something changes, right? Like you change the button from blue to green. Now, what should happen automatically? So this is a DevOps, like the infinity loop. So we have to plan the software, then we code the software. Right? Okay, we develop the code, then we scan for like vulnerabilities, or like best practices and all. This one we can like static code analysis, and we have a dynamic code analysis or different tools available. So whenever you push the code, we make sure, okay, this code is clean and no issues. This is called a security shift to left actually. So instead of you monitor the application for vulnerabilities, you can test the application before you build and deploy. Then you have to build it, test it. Then yeah, this is a kind of a continuous infinite loop. Integrate it, release it, then you test it, then deploy, operate, monitor. Yeah, it will be like that. So this is not going to end, because whenever there is an issue or something like a bug, then you will report it back. Then you have to plan it again, code it again. Yeah, this is a flow. This is like some other flows or stages I just mentioned here. There might be many stages depending on your environment, depending on your organization, workflow. Yeah. Now, where should I deploy the application, because it's already built and ready to use, right? So we have, earlier we used the bare metal servers. Then bare metal servers like just one server, like when one machine. Then you deploy an operating system like Linux or Windows X or kind of thing. Then you have your operating system. Then you have your libraries, application, and so on. Now we have a new technology, not new now, uh, called virtualization. So we will have a hypervisor software like a VMware kind of thing. It can be VMware, it can be KVM, or it can be other hypervisors, Zen and all. And on top of that, you can create multiple virtual machines. So it will have its own operating system, libraries, and you can deploy application. So this is far better, because you can share the resources from a bare metal or physical server. Now it was good actually, but we have a new term coined called microservices, containers, and now we have this term called containers. So containers, it can be a virtual machine, it can be a physical server. Then you have installed the operating system. On top of that, you have a container engine. Then you have multiple containers for the application. Very simple. So you are again maximizing the utilization of your computing resources. So you know the terms like Docker, Podman, Kubernetes, Red Hat OpenShift, and all. So you have multiple options for deploying the applications, and you know the pain and you know the pros and cons for using different applications. Like if you are using virtualization, like if you are using AWS or Google Cloud, okay, you can create VM using automated way or manual way, or if you are using the containers, we have different ways for deploying these application to the production container platforms like Kubernetes or OpenShift. Okay, this is a very high level. I think we still on time. Okay, good. Now, we have some more automated way of provisioning the infrastructure, which is called infrastructure as code, because everything is a code actually. So instead of creating the infrastructure manually, like going to the AWS console or going to the VMware console or going to the Azure console, you can use the IAC tools and provide the uh, code which contains the instruction to manage, create, and maintain the infrastructure like servers, storage, networks, security rules, policies, network, VPCs, kind of thing. This is the good thing, because you always have a single source of truth. Instead of going to the console and change it manually, or instead of using the CLI commands, you just change the code and update the infrastructure. What is a good thing? Something goes wrong, you can still go back to the previous version. But if you are creating it manually, then yeah, the rollback is not easy, because you have to delete it, you have to reconfigure it. But if you are using the IAC or infrastructure as code, the tool will take care of the rollback. It's very good, right? Now, some of the tools are like external tools like Terraform, Pulumi, Ansible, but some are like a cloud-based one, like a CloudFormation, Azure templates, and all. Now, these are like for the development thing. It's okay. Just ignore for now. So these all are a part of the DevOps, part of the application deployment. We know several components and phases involved. Now we talk about Ansible automation platform. So Ansible automation platform is kind of it's a simple, but it's a powerful product to automate most of, I will say, all of our IT and application infrastructure components. It can be cloud, it can be database, it can be your private or public cloud, your host like Linux, Windows, X, whatever the operating system versions. Then it can be your network devices like switches, firewalls, like Palo Alto, Cisco, FortiGate, any network devices. Then it can be your like your container platforms like Kubernetes, OpenShift. You can use Ansible to automate every operations. That's a beauty of Ansible automation platform, and you don't need an agent to be installed on the host. Okay. Now, if you are already familiar with the picture, let me explain again. Here, these are the very high level components or overview of the Red Hat Ansible automation platform, where you have the main UI, and now it's not calling Tower anymore. Sorry for that. I couldn't find a correct picture here. It's called Ansible Automation Ansible Navigator. Sorry, Ansible Controller, where you have the GUI, where you can access the entire controller, the controller interface from the web browser. You don't need to deploy any application. Then you have Ansible engine, which is the Ansible core, which is part of the Ansible automation platform. And you have some other cloud services like Automation Hub, Analytics like Insight. Then it will control all the infrastructure like network, security, cloud, Windows, Linux platforms. Now, if we talk about the latest Ansible one, because I mentioned Tower because many know, okay, Tower was the old name for automation controller. Now we call it automation controller. Then we have execution environment, which is a Python-based container images. Then you have automation mesh for automating and scaling your automation landscape to the different areas or different zones or different locations. So we are not going in detail because it needs a lot of time. Then we have also some tools for analytics like Ansible, automation service catalog, and also the Insight. Insight will collect the automation details or job details and propose you, okay, what you can do or what you can do in terms of increasing the efficiency or how much you can save in terms of time and all. Okay. And this is a high level overview of the components of Ansible automation platform. Actually, we have like more than 17 open source projects behind this Ansible automation platform. And these all are open source. Anyone can access and install by themselves. Like you can install the Ansible builder just like using the DNF install or the pip install. Ansible Navigator, you can install using the pip or DNF or YAM. Then the automation control is the Tower, or you call the Ansible AWS, is again open source. So most of them are open source. Not most, actually, all of them are open source. Sorry for that. And you have also a Microsoft VS Code plugin, which will help you to configure your development or because IDE, right? With the plugin. So it's a featureful one with auto completion, help on the screen kind of thing. Now, this is the very base or core of the Ansible, which is called Ansible Core. Earlier it was called Ansible Core, then we call it Ansible Base. Now it's called Ansible Core. Okay, this is the main building block of Ansible. This is a real Ansible. So this Ansible Core will take the YAML-based Ansible playbooks and will execute the task based on the module. So you can see on the screen, it's very simple module, simple playbook where you are installing something like, okay, copying some files, Then you are creating some directory, installing packages. This is the beauty of Ansible. You don't need to learn any programming language to automate Ansible or develop the playbooks because it's all YAML. YAML, you're already familiar with the YAML, I believe. Like you are using the YAML format for the Kubernetes, OpenShift, and all other DevOps tools. And anyone can read and understand, okay, what this playbook is doing. So you don't need any special skill to understand this. And most of the resources are available as open source, and you can download it and use it without paying for it, like no subscription fee, nothing actually. So you pay nothing for the open source and the community based roles and playbooks. Another things at all is a human readable, and this is a good thing because you can share this content. Let's say you develop some playbook or some Ansible automation content which you think, okay, it will be useful for the community. Okay, contribute it. You can contribute this playbook and roles via Ansible Galaxy. That's all because collaboration. So maybe when I use that, okay, I saw, okay, this code I can improve by adding or changing something, then I can put it back. That's called open source development, right? Now, the good thing about Ansible is a pluggable architecture. So you can add any number of or any kind of modules to the Ansible. Like you can see, we are using a copy module, we are using a file module. Let's say we don't have a module available. These are simple scripts. Okay, you can use your own language like Python or something and develop your own module and contribute it. Or you can use the standard shell commands or the CLI commands. Now, the question is where I can use Ansible for automating in DevOps. You can use Ansible automation platform in actually most of the phases actually, but the best practice is very simple. Use the right tools at the right place, right? You can use Ansible for building the application, scanning the application, testing the application, merging. Yes, you can use it. Also, you can use Ansible for continuous delivery, like storing the images to somewhere in the container or storing the artifacts to somewhere kind of thing. Also, you can use Ansible for deploying the application to the production system. Okay, now, in our case, we are talking about a lot of tools in DevOps, CI/CD kind of area. Okay, I just put few logos, like well-known logos or well-known tools here. We are talking about two-way automation. You can use the tools to call Ansible to do something. And also you can use Ansible to configure and execute some on the tools. This is a two-way automation. Okay, you can use Ansible. For example, Jenkins want to do something which you cannot use simply Jenkins bash script or some commands because that's not flexible. It's like a shell script or shell commands. Instead, you want to use Ansible playbook, and you don't want to keep the credential in a Jenkins. You can keep the credential in Ansible automation platform, which is safe, which is encrypted also. And Jenkins will just trigger and tell Ansible, okay, do this, deploy this, or something like that. Also, Ansible can talk to Jenkins or other tools to configure something, update something, create some pipelines, or that kind of operation. That's called two-way automation. Now, this is a very kind of a typical workflow here. The developer will push the code to repository, so there will be like code review or code review, and someone will approve it, then merge it. So the merge can be automated, or merge can be happen when after the automated testing, right? So in our case, okay, it's in the Git repository, then it will trigger a CI/CD pipeline. So in the CI/CD pipeline, what will happen? The tools, for example, Jenkins here, will do the code merging, then it will do the scanning. It can be before or after, depending on your workflow. Test it, do the integration test, do the other tasks. And you can use Ansible for scanning, you can use Ansible for deploying, for most of the operations. Or you can use Ansible to build the server, provision the new virtual machine, or install these applications like a Java or web servers, and finally deploy the latest version of application. So whenever there's a new change, again, the same workflow will happen, and Ansible will take care of the deployment or whatever the operation you want. Okay, this is a very high level one, typical one. Now, this is kind of a theory part. Now we will have a demo based on the workflow we were discussing, how we can implement it and talk each other, like Jenkins can talk to Ansible and Ansible can talk to Jenkins. Okay. For the demo environment, it's simple. We will be using the similar items here. So we have a developer who will be using the VS Code as the IDE. Then we will have Gitty. Gitty is like a GitHub or GitLab is a very lightweight version control or source code management software. Then we have Jenkins as a CI/CD tool here. Then you have an API. So Jenkins will call API on automation controller and trigger some automation job, and automation controller will take care of the deployment, building the application, and all. Okay. Let me switch my screen here. Okay. Now, so this is a challenge summary. So we will be testing some CI/CD workflow here. So the first thing, we have a lab, very simple lab where we have VS Code, then we have a Gitty, I mentioned as a repository one. Then we have a Jenkins running here. Okay, let me log in. Then we have a Ansible automation platform. Now, the VS Code, we can see this is like I am not sure it's visible. Let me know if it's not visible. Okay, so here we have the playbooks for the automation, like let's say configure Jenkins. So I have a playbook to create something on the Jenkins side. Then I have a playbook to release the applications. So you can see it's using some URI module and calling some API. Then I have a playbook for deploying the application. So these are like, I have some playbooks, and also I have an application directory here where I can see some repository for the application. If I check here, you can see all the Python code here. This is a Python-based application. So Gitty, this is the same folder you can see here. Then we have a Jenkins as a pipeline, but no build started. The controller is here, and we have something configured. Now, what we will do? First task is to So the first task is to change the pipeline, because right now, if you check, if you're familiar with the Jenkins, I have a pipeline already configured, and I have some stages and steps here, right? So it's saying, okay, getting the code, installing some packages. You can see the Python 3, and it's installing the requirement and dependencies. Then you have a static code checking using Python. Then you have using the Python lint actually build tag, so it will build and push the software to the repository. I mean the Git one. Then you have some kind of stages here. Now, if you check actually we don't have any deployment kind of operations here in the pipeline. You can edit here and save it. That's one way. But we want to automate this process, right? Maybe something goes wrong, or you want everything in the code. Instead of someone change it, you want to automate the pipeline as well. So what we have is the controller, and we have a job template configured to configure the Jenkins job. What I have to do is just simply launch the template. Then Ansible automation platform will talk to Jenkins over API and configure this pipeline for us. Let's wait for the job to finish. You can see here. Okay, let me go back. Wait for the job to finish. So now we are talking from Ansible to the Jenkins server. So it says, okay, job completed. Now we go and check the pipeline again. Okay, there is an additional stage now, which is calling the Ansible tower. Ansible tower means Ansible automation controller. And it says this is my tower and this workflow. Okay, I need to execute a job template called DevOps workflow. So if you check the template, there is a DevOps workflow job template. So Jenkins is saying, okay, as a last step, this job template should be executed, and inside the job template, there is a workflow actually. It will contain a lot of steps, kind of a building and all. Let me show that here. So this is a workflow here. You can see, okay, it's deploying to prod, then creating the release, then configuring the web servers in parallel, then deploy the application. Okay, great. Now we have pipeline configured automatically without any manual work other than the automated configurations here. Okay, that's good. Now we check and proceed with the next task, which is update in the application, because now the application is not deployed anywhere, right? Okay, wait for that. Okay, now it says, okay, this is our let's use application, very simple, some web page, but it says, okay, the service is not able to connect or no service available because the application is not deployed. So what you have to do is, first thing, this is the our application source code. We have to change something. Then only the workflow will trigger, right? Because in the Jenkins, so in the Git, if you check the settings, we have a webhook already configured. So whenever there is a change in the code, this webhook will be triggered. That means our Jenkins pipeline will be triggered. Now I'm going to change something here. So I go to the templates, queues, and I change the home.html. So I want to change this. Okay, this is a line we have to change. So what I'm going to do, I just copy the text, paste the new line, I save it. What will happen, because the VS code is already integrated with your source control management, it will show the change here. Okay, you change something on the code. Now we have to push this update. Okay, we have to push these changes to the Git repository, but you can do it in the command line way or anywhere, like a git push, git commit kind of thing. I'm just using the GUI based buttons here. That's it. I think the changes and go to the Git and Git. I check the repo. I can see there's a change a few seconds ago. Now we go to the Jenkins and see anything happen, because as per the configuration, if something was changed, something changed, the Jenkins pipeline will be triggered, and yes, we can see a pipeline already triggered here. Okay, so this is the automated pipeline here. We have it's just doing the pipeline. We have created the, like, getting the code, installing packages, doing the code checking, like code scanning, and it will also do the last stage we added, which is the automated task from the automation controller. Wait for that. So these are like we just updated the VS code only. Now it says, okay, this installing package, static code analysis, all done, all good. Okay, it's pending somewhere in the DevOps controller DevOps phase, and it's still like it's going on. So if you check the logs here, open this one here. You check the console output, we can see this code is doing something. Maybe it's a workflow which is running on the automation controller, Ansible automation controller. So what we will do, we have to check the Ansible automation controller and see what is happening there, because it's running for a long time and why it's not finishing, right? So if you check the automation controller, actually we have a approval stage here, because we are deploying to the production, right? So here you have a development happened, VS Code, you developed, then Git, you pushed, then Jenkins trigger the job. Now it's under the automation controller. Because you are deploying the application to production, we just included an approval phase. This is not really like mandatory. You can just make it like automated without an approval. But the ITSM flow or formalities where you have to approve the changes or approve some deployment to the production. So you can include that in the automation controller. Okay, now we go and check why it's